Hello everyone, so today I'll be discussing question number 31 of GATE 2007. A rigid bar is suspended by 3 rods made of the same material as shown in this figure. The area and length of the central bar are 3A and L respectively, while that of the 2 outer rods are 2A and 2L respectively. If a downward force of 50 kN is applied on the rigid bar, the forces in the central and each of the outer rods will be. So we need to find the forces in these 3 rods. 4 options are given to us and it's a 2-mark question. For this type of problems, you can refer to lecture series on strength of materials by Professor S.K. Bhattacharya, Department of Civil Engineering, IIT Kharagpur. Let's see how to find a solution for this problem. Starting with, let's consider this as rod 1, this as rod 2 and this as rod 3. Consider the force in rod 1 as P1, this force as P2 and this as P3. Since P1 and P3 rods are similar in geometry as well as in material properties, therefore they'll carry same force. So P1 equal to P3, let's call it as P. Moreover, since this is a rigid rod, so the displacement, it will remain straight. The displacement, that is displacement of rod 1 will be equal to displacement of rod 2 will be equal to displacement of rod 3. Delta 1 here is P1 L1 divided by A1 E1. Similarly, delta 2 will be P2 length of rod 2 divided by A2 E2. Here P1 we do not know right now. L1 length of rod 1 is 2L. Length of area of rod 1 is 2A and E1, let's say it is E. P2, what is the length of rod 2? It is L divided by what is area of rod 2? It is 3A and it's E. From this we get P2 will be thrice of P1, or here we have considered P1 as P, therefore P2 we can write it as thrice of P. So this is the relation we got. Another thing to note is that when we satisfy the vertical equilibrium in this case, then P1, now if we satisfy the vertical equilibrium in this case, so from there we get P1 plus P2 plus P3 should be equal to applied load 50 kN. P1 and P3 we have considered as P here, so P plus P2 plus P equal to 50, 2P plus P2 equal to 50 kN. Now from this relation we know that P2 is thrice of P. So we can write now P2 as thrice of P equal to 50 kN. From here we get P is equal to 10 kN. Now if P is 10 kN, then from this relation again P2 equal to thrice of P. So P2 will be equal to thrice of this P, that is 30 kN. Therefore we get the values of both P1, P2 and P3. P1 and P3 are equal to 10 kN, while P2, that is the central rod, will take 30 kN. So from the options, the answer is option number C, that is the central rod will carry 30 kN and the 2 outer rods will carry 10 kN each.